Okay, what is rectification? Rectification is talking about process of converting AC to DC. Okay, so it means because AC is current will be flowing two-way, either forward or reverse. Okay, by this process we can convert this to something like this. Okay, so in this question we'll be dealing with this full-way rectification. Okay, full-way rectification. Okay, first you have to see resistor R is connected across AB. Okay, this is the position of A and B. Draw a circle around the diode that conduct when S of the input is positive with respect of Y. So you have to understand how the current flow. Okay, for example, you have to consider when S, the middle S is positive, then the current will be flowing from here, go to here. It will not go here because it will be blocked by this diode. As we know, diode will only allow current to flow in one direction. So when you flow to here, you come to this junction again, it will be blocked again, so you can only passing through here, and then passing through B, go to A, and then find a way to return. Okay, it is you cannot go back to the same way because the current come out from somewhere. You have to find the other way to go back home. Okay, you not go back to the same path to the X. You must be finding a way back to the negative terminal. Okay, so for what we can see here is we need to circle the diode that conduct. Conduct means the current will be passing through when S is positive with respect of Y. So it's talking about upper part is positive, so it's actually exactly the same with this. Label, okay, circle the diode, so we know as what we can see, current will be passing through this and this, so we have to circle these two. Okay, so this is how you earn the first mark. Label the positive and negative terminal of output AB. AB is here, so you can see that is coming from B and then going to A. So B must be positive, A must be negative. So just have to label the positive and negative on this AB. So this is another mark for you. Okay, after that let's go to the next part. Variation of time with the potential difference V across the Vs is given by this equation. So we know the general equation for the potential difference is V naught sine omega t. Okay, so you have to pay attention to the unit. Time is in second, the volt is in volt, the potential difference is in volt. The variation of with time rectified, so this is a rectified potential difference across the R. So as well, we can see this is a full-way rectification. Use the expression for the input, otherwise determine the root mean square of this. Okay, root mean square, so there is a relationship. Root mean square, I think all of you know, this is V naught over square root 2. V naught will be the peak potential difference. So can you see the value of peak potential difference? So you need to read from here. Okay, so we can see this is 5.6, 5.86. Okay, so this is 5.6. So you need to take this 5.6 divided by 2. Okay, so this one from calculator should give you 4.0. Okay, don't forget you have to give the answer in 2SF. So this answer. After that, okay, next part, the number of times rectifier potential difference reaches peak value. I think you should know. Okay, this is original wave, now have been rectified to this shape. Okay, this shape. So this is one cycle. Okay, so this is the period. So to here, this is another period. So as what we can see, in one period, there are two peak value. Okay, two peak value. Now we are looking for the number of times per second. So this is N over T. N over T basically will give you the frequency. How can we find the frequency? So then you have to refer back to the equation. So from here we can compare. This W is 380. So just take a tick. W is 380 radian per second. So we have another relationship. Okay, this one is the number of oscillation per unit time. So omega is also equal to the 2 pi f. So we'll be able to find the frequency from omega divided by 2 pi. Okay, so what is the value when you divide in this way? Okay, so this one should give you, okay, from calculator, if you press calculator, this is 50.5 Hertz. Okay, this is the number of oscillation per unit time. Okay, if you go and study the definition for frequency, it has to be the number of complete oscillation per unit time. So from here we can see this is one complete oscillation. Okay, so after rectifying, this is the complete oscillation. So we are looking for that means this one there are 60.5 complete wave in 1 second. For every complete wave, we are going to have 2 peak value at the same time. Okay, so the number of the peak value you have to multiply by 2. Okay, so this one give you 121 Hertz. And this 121 in the A-level exam, you have to give answer in 2 significant figure. So in this one, you can only write 120 times per second. So this is the answer. Okay, so if you are able to link this with this, you can get 1 mark here. If you can find the correct answer, give you another mark here. Okay. Okay, next one. C. A capacitor is now connected between the terminal A and B of output. Capacitor reduces the variation of ripples to 1.6. Okay, the meaning of ripples means when you install, okay, when you put another capacitor here, okay, then what will happen now is, okay, for the full wave rectification, okay, let me explain again about how the capacitor function. So for this capacitor, there will be 2 functions. Let's say this is T1 and this point is T2, and then this is T3, and then it will go up again. So when the potential difference increases, that means from T1 to T2, the diode is being charged, because when the current coming in, it will passing through the capacitor and resistance at the same time. It should be go the other way. Okay, so this is a charging process, charging until it becomes fully charged. After it becomes fully charged, when the potential difference from the source is decreasing, then the capacitor will start working. It will start discharging. So there are 2 processes here. T1 to T2 is charging, and T2 to T3 will be having discharging. Okay, discharging. And then the process will repeat again. So this is one complete one. Then it will go back to the charging process again. Maybe this is T2, and then discharge again, charging, then discharge again. Then the process will repeat. So the variation is actually this part. Okay, so there's a ripple here. Okay, as what we know, if the discharging process, charging depositing process is very fast, you're not going to see the ripples. So this ripple will be gone. Okay, what we will see from the naked eye is actually a constant potential difference. So it becomes constant. Okay, so in this question you have to try to understand the question again. Okay, sketch smooth curve, okay, or variation. So the variation of ripple is 1.6. That's what we can see from here. The highest value is 5.6. When it's having discharging, you have to minus 1.6. Okay, and then the value will drop to 4. Okay, actually this one implies that the lowest value for this one will be 4. Okay, so you have to know. Okay, go back to 4. That means this thing will start discharging until reaching 4, and then That means it will go here, discharge until 4, then go down, 4, here, go up, go down, go up. Okay, this is the variation of 1.6 volt. Okay, that means from the highest value drop to the lowest value, the difference is 1.6 volt. Okay. Okay, after you have sketched this one 4 marks for sketching. Suggest and explain the effect of any on the mean power dissipation in the resistor R when the capacitor is connected between the terminal A and B. Okay, the mean power. Okay, we have to focus on mean power. Mean power is mean value of, can be in this form or in this form. Okay, so in this case, what we have is the changes for potential difference. So we have to explain by using this. Okay, what will happen? So as what we can see, if it's without the capacitor, it's dropped to 0. Okay, every time the potential difference will rise from the 0 to maximum, back to 0, and then like that. So by introducing the capacitor, we can see that the potential difference become more stable. So it will be somewhere here. Okay, the mean value will be somewhere here instead of here. Okay, so without the capacitor will be here. With capacitor, that means it will go up to the upper part. So as what we can see here is you have to comment. Okay, so what is the effect? So since the mean potential difference is increased, since mean potential is increased, so the mean power will increase. So mean power will increase. Okay, so it's by using this formula, you'll be able to answer this question. Okay, that's all for today.